Hello everyone. I want to take a look at an example of writing the equation of a circle when I'm given a point that is on the circle as well as the center of the circle. So normally when we're doing this, we know the center and we know what the radius is. In this case, I don't know the radius, but I know a point that is on the circle. So if I'm given the center and I'm given a point on the circle, the distance that's in between these 2 points, that's the radius. The radius is the same everywhere, so it doesn't matter where that point is on the circle. The distance from there to the center, that's the radius. So we have a couple different ways we can approach this. The first way, I could just use the distance formula to solve for the radius. Otherwise, if we just recall our standard form equation for a circle, we can use this to find r as well. The center, this is h and k, and the point that's on the circle, this is just a pair of x and y. So I know h, I know k from the center, I know x, I know y from the point I'm given. That only leaves r as the variable we can solve for. So if we plug everything in, x is -5. Okay, this negative sign is built in, so you got to be careful. So it's minus a -1, so it turns into +1. Y up here is 6, and then our value for k is 3, and that just leaves r as the one variable. So let's see what we end up with. So here we get -4 squared. 6 minus 3 is 3 squared. 16 plus 9 is equal to r squared. So r squared is 25. And then taking the square root of both sides, we end up with the radius of 5. However, I'm not even going to go that far because I know for my final standard equation, I'm plugging in r squared anyway, so I might as well just leave it like this. So then to finish this up and to write the equation of the circle, we're going to leave x and y as is, and then we'll plug in the center. So we had +1, and then we have y minus 3. So y stays the same, and then we plug in the value for k, and that is equal to r squared, which is 25.